Hello, and thanks for watching. I've had in my head for 30 years this time relative motion thought experiment, which seems to disprove the theory of relativity. I know I'm missing something, but I just can't figure it out. The thought experiments I have seen, proving time dilation with relativistic speed, all have variables that start the experiment at one place and end the experiment at another place. This creates perspective problems and ruins the experiments because observers are not actually measuring the same things. This thought experiment eliminates these problems by having all the variables together at the beginning and at the end of the experiment. We have two observers, A and B, carrying identical clocks. Observer A is stationary. Observer B is on a train traveling on a 186,000-mile track at 1/10 the speed of light, 18,600 miles per second. Once per revolution, B reaches A, and at that instant they are at the same point in space. A's clock would surely measure 10 seconds for each of B's trips around his circular track, while B's clock would predictably show less than 10 seconds because, according to the theory of relativity, the ticking of his rapidly moving clock is slower than the ticking of A's stationary clock. Here we are again, A and B. B is traveling around the track, A is stationary. Once per revolution, B reaches A and they are at the same point in space. It is from one of those points that a pulse of light is released toward the first of a series of mirrors, 186,000 miles apart, arranged in space to reflect the light around the path until it gets back to its starting point. As the experiment begins, the pulse of light is released toward the first mirror, A and B start their clocks, and B continues on his 186,000 mile path. At the end of the 1,860,000 mile journey, the light returns to its starting point at A as A and B turn off their clocks according to their perceptions. As they were at the beginning of the experiment, A and B are presumably at the same point in space. They have both measured the time interval between the release of the pulse of light and the return of that same pulse of light to its origin after completing its 1,860,000 mile journey. A's clock would surely show 10 seconds, as any other finding would contradict Einstein's second postulate of the theory of relativity that the speed of light must always be measured at 186,000 miles per second. 10 seconds is how long it would take for light to travel that far. Observer B's situation is more complicated. Though he has witnessed the same events from the same point in space and time as A, Observer B has been traveling at relativistic speeds during the experiment. According to the theory of relativity, B should show less time elapsed on his clock because his rapidly moving clock ticks slower than A's stationary clock. But he should also show 10 seconds on his clock because the theory of relativity also states that any observer, regardless of relative motion, can find only one measurement of the speed of light, 186,000 miles per second. And light has inarguably traveled 1,860,000 miles while B's clock was running. Obviously, B's clock can't show 10 and less than 10 at the same time. If B's clock shows 10 seconds, then there has been no time dilation with relativistic speeds, disproving the theory of relativity. If B's clock shows less than 10 seconds on his clock, then he has measured the speed of light to be higher than 186,000 miles per second, also disproving the theory of relativity. The speed of light is the speed of the dissolution of matter, the highest speed possible. Now, I'm sure I'm missing something a sixth grader could see in an instant, like maybe time dilation and length contraction working together to make B measure space differently, but I just can't get it to work. If the speed of light must be measured the same for any two observers, regardless of relative motion, B's clock must show 10 seconds and the theory of relativity is wrong. Please comment.